Here we go with a little overview about independent variables, dependent variables, and how you can make specific hypotheses from that. So a review first, the independent variable, that's what the experimenter selects to be changed, because that is what we want to see. What happens if I modify this? What is going to go on? The dependent variable depends or reacts to the independent variable. Okay, so the one that you typically see in biology class is the one with the plant. If I change the amount of water, will the plant grow more or less? And so if I change the amount of water, that is my independent variable. Then it's affected by something. Then the height is the dependent variable. Okay, and then the controlled variables, which sometimes you just call as the controls, those are the things that should not be changed in the experiment, and they should be kept consistent the whole time. So if you want some help on remembering which one to plot where, dry mix is your friend. Dependent, or the dependent variable, responds to the x. It reacts to what you changed, and it's plotted on the y-axis. Mix, manipulated, it's the independent and on the x-axis. So dry mix. So if you're trying to remember which one goes where, and here's my little handy if then. You've often done if then hypotheses in many districts, but we're going to add a because in there because that's making it more specific and more accurate. But that will help you find the IVs and the DVs, because if is what we're doing. If we do this, then this happens. Okay, the one that responds to what you did is the dependent variable. Okay, so here we got a little graph here. Is this an independent? Is days since we met independent or dependent? So you can answer this two ways. According to the graph, it's a dependent variable. But then let's take a step back. Days since we met, that's reacting to your happiness. This graph seems like it might be backwards. So even if they give you a graph, take a second to think about it. Is that actually the IV or the DV? Okay. Okay, so we are not changing our happiness. In terms of time can be in either place in chemistry class. When in doubt, you can put it still on the x-axis like you do in biology, but things like exponential growth or reaction rates is not going to follow that process. So that's only if you're at a super loss and putting it into the hypothesis formula does not happen. Okay. Are these guys poor or good choices for independent variable? So time can be a good choice. Height can be a good choice. Sadness is not measurable. Same with that happiness earlier. Could time and height both be dependent variables? Definitely. So again, think about what's going on. And that's why making specific hypotheses are really helpful. Okay. All right. So let's see if we can test this. All right, some recipes for bubble blowing solution have glycerin and others do not. How does adding glycerin to the bubble blowing solution change the size of the bubbles? So what are these variables? The brand of dish detergent used. Okay, so the dish detergent does not have glycerin in it. That's something else that you're adding. So your brand of dish detergent and even the specific type of dish detergent should be the same, making that a control. Bubble wand company and size. If you have two different size bubble wands, your bubbles are going to look different. So we're not going to be able to measure how the glycerin is affecting that. So again, that is the control. I say color on here because sometimes you have one plant or one line that does red and another plant or another line that does blue, and they might have slight differences. So technically, you don't have to do color. I'm just pointing it out that sometimes you have some error in your calculations that you would not have considered, because just changing the color obviously should not affect this reaction. The amount of glycerin added to the bubble blowing solution. The amount of glycerin, okay, is the amount of glycerin reacting to what you did, or is the amount of glycerin what you are changing? How does adding glycerin, that's what you are changing. So that is our independent variable. The weather conditions outside when blowing the balloon. Okay, so that should be controlled, but we might not be able to actually control it so well. So you need to record it on each experiment, and then you might have to redo some of your trials because that messed up your answer. Whether or not the neighbor's dog is barking, the first time I used this, I put it in there just to be funny, but I got a lot of great responses on that. If the dog barking scares you while you're doing the bubble blowing, could that affect your data? Yeah, it could. So again, maybe record that each experiment. And it is your choice if you decide that is something that does not need to be recorded, but there is definitely been some information from my students that it is important. Okay, now in this one, I didn't have you label the DV. That's okay. That's so that you could just make sure that you're answering the specific question. Don't just go, well, this number 5 has to be the DV. It doesn't always work that way when you're doing those items. All right. Student 1 holds the ruler vertical at the 30 centimeter end using 2 fingers and drops the ruler. Student 2 puts the top of their index finger at the 0 mark and their thumb on the other side and does not touch the ruler. You've probably done this before. Drop and catch and record the centimeters. This time we got to figure out what's going on without the problem statements. So sometimes they can just give you a procedure. Okay, so the distance recorded, is that going to be my IV, my DV, or my control? If we drop the ruler, then I will be able to catch it at blank because of my reflexes. If I drop the ruler, then, so in this case, I got a then for where I'm going to catch it. Okay, so even if you can't get the specific words into specific IVs or DVs, when you walk yourself through that if then because process, it will help you figure it out, that distance recorded is the dependent variable, because that's what we're measuring. What is happening when I drop that ruler? So now let's get into a hypothesis is a proposed or educated guess. It should have math or observations backing up this statement. So in your first statement now, if the IV, then the DV, because key terms, you're going to put a little bit of your data there, and then you're going to put more of your data in the actual paper. Okay. So if I have chores, if I do chores around the house, I will be paid an allowance because that is the parent's law and was observed by my older siblings. Obviously, that is not a parent's law. Your guardian can do whatever you want there. But in terms of this household, they considered that the law, so they use that for the key term. If chores, okay? So the chores are what you are deciding to do. So that is going to be your independent variable. Then I will be paid, okay? Then that is your dependent variable. How much you will be paid is your dependent variable on that, set up by the specific situation in that house, just like set up in the specific science framework that you are using. All right. So here's an actual IB or AP Chem lab that is used. An eggshell is mainly composed of a compound called calcium carbonate. One of the following solutions, milk, vinegar, vegetable oil, water, will react with the calcium carbonate eggshell, producing water, carbon dioxide, and other compounds, leaving only the membrane surrounding the yolk. Predict which solution will react. Okay, so predict, that means they want me to come up with a hypothesis. Okay, they gave me the problem statement. I want to do the hypothesis. If then because format, I need to figure out the IV and the DV and then explain what key terms. So what is my independent variable? What is the experimenter changing? The experimenter is changing the type of solution. Okay, that means that would go on the x-axis. The dependent variable, what are we going to be measuring? We're going to be measuring something about the eggshell. So something about the eggshell, percent dissolved, how much of the calcium from the eggshell went into solution. That is one thing that you could be measuring. That would go on the y-axis. If we use different solutions, milk, vinegar, vegetable oil, and water, and place an egg in those solutions, then a percent of calcium carbonate will be dissolved according to which solution is used. The vinegar would have the most percent dissolved because it's an acid. So I gave a really, really long hypothesis that way, but I still touched on all those parts. If IV, then DV, because you could even make it a little bit shorter. There is an example right there. Make sure when you're doing your proposed guess, you also guess the answer. Okay, so if we do this, then this happens. Make sure that DV part is going to include what your hypothesis is. Okay, because so if you just had said, if we use different solutions, then we'll have different percent dissolved rates. Okay, that is not going to be as detailed enough. Decide, pick one. It can be wrong. It is okay for hypotheses to be wrong. It's not okay if you change your hypothesis after you get more data. After the whole experiment's done, then you can say, okay, now I'm going to revise my thought process based on this paper or this study or this experiment. And that's true science. The controls, do make sure same eggs, same amounts of each solution, same molarity of each solution, etc., etc. And there's that exit slip so that you can look through that, hit pause and see how you do. Okay, so we are using different calorimeters, different measures of the methane combustion. So you're like, well, that shouldn't be affected. No, they should all be calibrated so that they are the same. But this person wanted to check that out. So IV would be those different calorimeters. Okay, and then what is your prediction? Okay, how will the temperature readings? Then the temperature readings will fluctuate or will stay the same. Could your hypothesis be the null hypothesis? Then the temperature readings will be still consistent because the calorimeter was all calibrated together to make sure that they were accurate. And have a good day.